So in this video we'll talk strictly about inequalities with absolute value. So I'm going to start it off in its most basic form, and I think once you get this down it'll end up being pretty easy once we add some more stuff inside the absolute value and outside of it. But let's think about absolute value of x is less than or equal to 4 in its most basic form here. What could x be? Well, it could be 4, could be 3, could be 2, could be 1, could be 0, could be -1, because that would make it a 1, could be -2, could be -3, could be -4, could be anything in between all of these, but it cannot be 5 and it cannot be -5 because -5 would make it +5. The absolute value would make it +5, and then it's no longer less than 4, right? So these are the only numbers that work, or whole number wise, and then or integers, and then in between we could have decimals and fractions. But to graph that, we're going to need, that's a pretty bad graph, isn't it? Let's try that again. So we need a -4 and we need a 4. And it's basically everything in between -4 and 4. And if you remember from 2 videos ago when we're graphing compound inequalities, this is an AND statement. It's the intersection of 2 statements, and those 2 statements would be that x is greater than or equal to -4 and also less than or equal to 4. Okay, so we're starting to combine all the different concepts we've been learning in all these videos. So anytime you have the absolute value of something being less than or equal to, it's always going to be an AND statement, a conjunction, one of these type of statements here. Okay. So what you'll notice about this is that the number on it basically stays like x is less than or equal to 4, just like it looks, except we also add in this part and do the opposite of this number. So for instance, if I were to do absolute value of x is less than 2, it would end up like this. Okay, notice that this 2 as a boundary is used on the upper end, but then on the lower end we use the negative version of that. Alright, let's move on to the part in red here. In this case, what answers would work? Well, what's greater than or equal to 4? Well, we have 4, we have 5, we have 6, and so on. 3 doesn't work, and 2, none of those, -2, -3. But once we hit -4, we are okay again. -5, -6, and so on. Because remember that absolute value makes it positive, and then so we can become bigger than 4 again. So if we were to graph this, let's see how it would look compared to the blue graph on the right. So we have greater than or equal to 4, so that's up here, and then we have less than or equal to -4, which is down here. So as you can see, this also looks like one of those things we were graphing a couple days ago. This is an OR statement. This is an OR statement. So these are OR and these are AND. And the way you graph an OR statement, remember, is just the two things separately. So we have x is greater than or equal to 4. And then this side over here is x is less than or equal to -4. But keep in mind that it still uses that 4, right? Over here we had the 4 and the -4, and over here we changed this 4 to a 4 and a -4. Okay? And that should be good. So let's go on to some more examples. Get some extra practice here. So if we had y plus 8 is greater than or equal to 3, oh sorry, this is an absolute value. So first thing to do is isolate the absolute value. So instead of isolating the variable right now, we're isolating the absolute value first, which in this case is already done for us. If we check back, the absolute value is greater than, which means it is an OR statement. So we need to say y plus 8 is greater than or equal to 3, or y plus 8, and remember, switch the sign now, is less than or equal to negative 3, because we're trying to go to the outsides of this line, right? We're trying to go bigger than 3 and less than negative 3. Alright, so now we're actually going to solve these individually. So let's bring this one down here. We're going to Alright, so now I'm going to subtract 8 from both sides, and we end up with y is greater than or equal to negative 5. And over on the right side, we have subtract 8, and we're going to get y is less than or equal to negative 11. And we graph that on the same number line, because it's all part of the same inequality. So we have negative 5 somewhere, and negative 11, and we need greater than or equal to negative 5, that's this way, and less than or equal to negative 7, that is this way. Let's try another. Okay, for this one we'll do 2v minus 1 2v minus 1 is less than 9. Alright, so the absolute value is already isolated. So now we just have to make our AND or statement. So when it's less than, when the absolute value is less than, it is an AND statement. So we have something like this: negative 9, 2v minus 1, and 9. So when it's an AND statement, we can solve it all at the same time, which is nice, a little easier. So we add 1 to all 3 parts. So now we have negative 8 is less than 2v, is less than 10. Let's divide everything by 2, and we get negative 4 is less than v, which is less than 5. And to graph that, remember, it is an AND statement, so everything needs to be correct. So we have a negative 4, a 5, and these are open circles this time, and we shade in between. Alright, let me do one more before I let you go. Let's do one where the absolute value is not isolated yet. Alright, I'll just make one up here. So if we had 3 times the absolute value x plus 2 absolute value minus 6 equals 12. Let's try that. So in this case, instead of isolating the variable, we want to isolate the absolute value first. Right now that absolute value is being multiplied by 3 and subtracted by 6. So we're going to try to combine the like terms right now, which would be the 6. The 3 can't be combined yet because, similar to a 3 being outside of parentheses, this 3 outside of absolute value means the same thing. It means it'll have to be distributed eventually. But I'm going to show you another way around that, because it would be hard to distribute into something that you don't know if it's positive or negative. So right now we have 3 times something equals 18. So instead of multiplying this 3 by, to everything, we can divide everything by 3, right? And that gives me a little fruit ninja there. And so we end up with the absolute value of x plus 2 is equal to 6. Now we can make our OR statement. Actually, before I do that, I wanted this to be an inequality, so let's make this an inequality. let's make it less than. There we go. Okay, now we can turn this into an AND statement by removing the absolute value. And now we subtract both sides by 2, or all three sides in this case. And we end up with all that. And to graph it, we have a -8, we got a 4, we got some open circles, and we graph in between, and that is it for graphing inequalities. Some people try to memorize whether this is going to be an AND or an OR. As you can see, you can also think of it logically by just writing down some numbers that would work and finding the high end and the low end, so the positive and the negative cutoff. So if you want to memorize it, that'll work. If you want to logically think about it each time, that'll work too. Thank you very much.